Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Syahmi bin Zainuddin. So today we are going to present about our product, which is a lajak kuruh tablet. We are from group K, will present about the pil lajak kuruh K. So this is our group members list. The first one is Faiz Izwan, Muhammad Zainuddin, Muhammad Ahmad Syahmi, which is me, Muhammad Syahid, Nur Syamimi, and Fadil Muhammad Haris. So now we are going through the introduction. Basically, the Lajak Laku is a manufacturer that produce health supplement diet tablets called Lajak Kuruh. So the company produce at least 15 types of Lajak Kuruh tablet with different health properties. So from the company, there is a 200 sample observation was taken at a random from the 3 production shift, which is morning, evening, and night in December 2020. So our group is going to analyze about pil Lajak Kuruh K. So the objective of our presentation is to analyze and ensure that the production of tablet are running smoothly and follow the standard by the Food and Drug Administration FDA authority.
Hi everyone, my name is Muhammad Syahid bin Maidan. Today, I will present for part A. Okay, all data given will be summarized into 3 forms, which is numerical form, tabular form, and graphical form. First, we start with numerical form. Data given in 3 forms, which is weight, relative density, and tensile strength. First, we calculate for the total of each of the terms. Then, we calculate median, mean, mode, standard deviation, and variance. Next, for tabular and graphical form, the data given has been classified into 3 different times, which is night, evening, and morning. We have summarized and sum up the weight, relative density, and tensile strength into these 3 different times. And as the result, we have been plotted 3 different graphs, as shown below. For more specification, we set data into a range and plot the graph. This is the data for weight and the graph for weight. And this is the data for relative density and the graph that has been plotted from the data. And last one, the data for tensile strength and the graph for tensile strength.
The FDA authority requires that the weight of standard tablets should be normally distributed with the average of 350 mg and a standard deviation of 14. We have to make sure our sample of data meets the FDA expectation. So, our team decided to carry out the goodness of fit test to check the normality of our sample weight. First, we determined the hypothesis of our data. H0 would be our weight sample follows the normal distribution, while H1 would be the other way around. First, we need to construct the frequency table in order to carry out the test statistics. It is important to note that the expected frequency should not be lower than 5. If it does happen, we need to combine 2 or more subgroups to make it larger than 5, as shown on this table. After the modification, we can find that degrees of freedom, instead of 9, now we have 7. The value of chi-square test can be found by adding all of these values. Step 3. We choose 0.05 as the significance value. The critical values found at this point is 12.5916, which makes it larger than the chi-square test. Thus, we fail to reject H0 at 0.05 significance level. In conclusion, there is no evidence to prove that the weight of Lajak-Curie tablets K do not follow a normal distribution with a mean of 350 mg and a standard deviation of 14, according to FDA. This sample is proven to follow a normal distribution.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fadil Muhammad Harits, and I will be presenting the Part C question, which is to carry out a hypothesis test to check whether there is any significant difference between the tablet weights from the 3 different shifts. Of course, the question required me to imply the analysis of variance or ANOVA method, which we are going to use 0.05 significance level, or alpha equals 0.05. And the first of which is to write our hypothesis test, which is to obtain our H null and H1. As you can see here, the H null is all the population means of the 3 shifts, E for evening, M for morning, and N for night, are all equal. And the H1, which is our claim here, says otherwise, which is all not the same. And we will reject H null if the p-value is lesser than alpha equals 0.05, or the f-test value is greater than the f-critical value. Alright, so we're moving on to the next slide. Okay, now so here we can see that we have managed to obtain the tabular information of the tablet weights from the 3 different shifts, and here we use Microsoft Excel's data analysis add-ins, and we choose the one-way ANOVA option, and we basically just input the 3 different shifts and the tablet weights data, and here we obtain the statistical results, the count, sum, average, and variances, and these are the most important ones: the ANOVA, where we have the sum squared, the degrees of freedom, the mean squared, the f-test value, p-value, and the f-critical value. And here, as we can see, the f-test value is far smaller than the f-critical value, and the p-value is much greater than the alpha, which is equals 0.05. And since the p-value is greater than alpha, therefore we are unable to reject H null at 0.05 significance level, which comes to conclusion that there is an insufficient amount of evidence to believe that there is a significant difference between the tablet weights from the 3 shifts. Therefore, we conclude that the claim is wrong. And if we see it from the graphical, in a graphical manner, here we can see that in the red area is the f-critical, and their f-critical 3.042, and the red area is alpha equals 0.05, and the blue area is the p-value, which is 0.286. And as you can see, the f-test is far greater in area than the f-critical, and the points themselves says the same. And I managed to obtain this this graphical data through www.statdistributions.com.
Assalamualaikum, I am Faiz Izwan Rusli, so I will explain about Part D. Part D is about a simple linear regression. Okay, A simple linear equation computes a straight line relationship between a single response variable, and that is our tensile strength, and single predicted variable, which is our relative density. With a sample of 200 tablets, we use Excel to generate 3 tables, which is table 1, table 2, and table 3. We're going to show later. For table 1, what we get is the data over here. The multiple R, which is 0.844, which is our interest over here. Okay, table 1 is for regression statistic. Okay, for table 2, what we get from Excel is this one. So what our interest say only for F and significant F, which is this value and this value. Okay, for the table 3, estimation of unknown regression coefficient, what our interest is over the coefficient only, which is intercept coefficient is our alpha and relative density is our beta. So from the table 3, we found that the value of P is small, which is this value. This means that the evidence is strong to describe there is a linear relationship. The target fitted linear regression equation is obtained by referring to the output coefficient in table 3. We know that the alpha is this value and the beta is this value. So by using formula of y equal to alpha plus beta x, we can calculate all the tensile strength needed for the question. So what needed for the question is 68%. By using this formula y equal to alpha plus beta x, then we can calculate this value, also this value and this value. So this is the predicted tensile strength needed from the question. Okay. When using both ANOVA test and t-test, we can see that we can conclude that the result from probability is lower than the chosen significant level. Thus, this indicates the beta is not equal to 0 at 1% of significant level. So we can reject our H0. Okay. Okay. Thus, this test support the evidence of linearity relationship that exists between tensile strength and relative density, since the correlation coefficient value multiple R equal to 0.844. This shows to us that there is a strong positive linear relationship between independent and dependent variables. Thank you very much.